Hello everyone. In today's lecture, let us discuss about the architecture of ARM. We are all using these kind of electronic gadgets. Do you know the processor inside this? Let us look into it. It is ARM. ARM is Advanced RISC Machines. Especially it is used in embedded systems and mobiles. ARM initially it is known as Acorn RISC Machines and later the name was changed to Advanced RISC Machine. Features of ARM. ARM has load store architecture, single cycle execution, it is energy efficient, it is scalable, customization and licensing is possible, which is a key feature of ARM. Then multi-core support also, that is different variants. Then it support 32-bit as well as 64-bit computing, and it is adaptable to various operating systems, reliable and secure. Other than this, its performance was very good. It has low power consumption. The size is very compact. It is small. And this is the reason why it is used in many higher end applications which involves handheld devices, automation systems and consumer electronics. When we speak about the ARM architecture variants, it has different variants. It has a large variant processor family. So see here we have the families. Here I've mentioned few like ARM 7, ARM 9, ARM 10, ARM 11, Cortex. So few I have mentioned here. In every families, different processors are available, and the processors differ depending on the features. So under this we have a few microcontroller families too. And coming to the ARM nomenclature, so ARM, this A stands for advanced, R stands for RISC, and M stands for machine. Along with this, see, here is an example. Here the 7, this stands for family. Other than this, we have few alphabets. So the meaning of these alphabets is that the abbreviation of these alphabets is mentioned here. Suppose if it is T, if it is mentioned T, then it means that it uses thumb instruction set. If it uses D, then it means that it's a debugger. So similarly, every alphabet in the name means the means different features. And here comes the architecture of ARM. Here the architecture of ARM looks very simple. Here we have an ALU. We have a 32-bit data bus and a 32-bit address bus. The addressable memory space is 4 GB. It has 37 registers with 7 memory banks. 32-bit registers each. The size is 32-bit of every register. It has an inline barrel shifter, which is a special feature of ARM. Along with this, it has multiplier, ALU, incrementer, address register, decoder, and control logic as like other processors. So we can see here we have the address bus, data bus, here the data incrementer, register bank. Then we have the multiplier. Barrel shifter is used to make the shift operations in single cycle. And that's why a feature is there, single cycle execution, which is a special feature of ARM because of this barrel shifter. So the input to the ALU can be either received, one input will be normally from the register bank and another will be through the barrel shifter. And the outputs are placed in the data out register, and the input it receives through the data in register. Here we have the instruction decoder and logic control. This is the architecture of ARM. And coming to the registers, we have, as I mentioned, we have 37 registers. Each 7 register banks are there, and size of each register will be 32-bit. And here comes the program status register. It is again a 32-bit register. Here, out of these 32-bit, the first LSB 5 bits shows the mode of operation. Then the next bit here, this one denotes the thumb state flag. This denotes the FIQ, that is fast interrupt request flag. Then this denotes if any interrupts are there, interrupt request flag. And here in the LSB 4 bits are there, which is normal, overflow, carry, zero, and negative flags. Here overflow is represented by the term V. Normally O will be used, and here in ARM, V was being mentioned. And so barrel shifter, and it shifts, it pre-processes one of the data before passing it to ALU. Multiplier normally is a 32-bit into 8-bit multiplier, and commonly Booth's algorithm is being followed by the multipliers here. ALU, we know the function of ALU is to perform arithmetic and logical operation. The same thing was done here too. And the address register holds the address of the next instruction to be fetched. PC also does the same. So this is an additional feature in ARM. Then we have the instruction decoder. Then different types are there, in data types. Whenever the data was being fetched, word, half word, bit, and byte. We need to know all the different data types. So how it is memory addressable? What is the size of memory? 32-bit ARM instructions are placed at word aligned address. And the byte order is in endian format. Big endian and little endian, two types are there. Suppose if the MSB is stored in the lowest address and the data is addressed by address of if the MSB is stored in the lowest address, then it is big endian. If the LSB is stored in the lowest address, then it is little endian. So that is the major difference, how the data was being stored. And here comes the bus architecture. So AMBA bus architecture, advanced microcontroller bus architecture. It has major buses. It provides the advanced high performance bus. It provides high bandwidth, multiple master slave operations was done. It has peripherals. It includes bus arbiter, decoder, etc. And this is advanced system bus and advanced peripheral bus. The advanced peripheral bus is used when it comes to UART transmission. And here are a few questions for review. And this is an assessment. What is the function of barrel shifter? And what is the size of the address and data bus in ARM processor? Thank you for watching.